Good evening, everyone. Let's begin with our discussion on EMV tokenization. Before getting into the topic, let me just spend a minute on introducing MVLco. So MVLco, meaning MVL Consulting Private Limited, was founded in 1996, and since then it has been a service provider in consulting, assurance, and training services. So many of you have already been associated with MVLco through one or the other courses or through other channels. And you may be aware that MVLco has been providing various testing, auditing, and training services to banks as well as IT companies. And certifications issued by MVLco in the areas of payments or cards, messaging, trade finance, etc. are quite widely accepted. So myself, Ameya Lonkar, I am one of the trainers at MVLco. I am a chartered accountant as well as certified information system auditor. So let's understand what is the agenda for our today's discussion. So for those who are completely new to the card industry, so we will have a quick 2 minutes discussion on the overview of card process flow so that all of us are in sync. Then we will discuss traditionally what have been the vulnerabilities or limitations prior to introduction of EMV technology. Now when we are going to talk about EMV, we are going to talk about two things. One is the chip card, and the other one is the contactless cards or contactless methodology, or what we call as a near field communication technologies. Those are being used under EMV. After which we will touch upon the tokenization. So what is this tokenization? How will it really help? How will it solve the problem, etc.? We will discuss that. We will discuss various token types: acquirer token, issuer token, EMV token. However, our focus for today's discussion would be more on EMV token, because that is what that I can say is more popular than the other two, or I would say a bit more complex than the other two. So once we deep dive into EMV tokenization, we will understand the additional entities who get involved in the tokenization ecosystem, how this token would work, what is this process of tokenization process flow, what are the benefits, and we will also discuss. So once we create this tokenization technology, how is it going to affect all the other processes or the key processes which are currently happening based on a primary account number. So that's how we will conduct our session. And at the end of the session, as I said, you can ask your questions and I'll be very happy to answer them. So let's begin our discussion. Let's first understand who all are the parties involved and how does a transaction really happen. So on your left hand side of your screen, you have a card holder, right? In our example, I am taking a case that he has an SBI card and it is also connected with a Visa network. So the first party I have in my canvas is the card holder who has the card. Now he has 4 channels wherein he can use this card. First could be your ATM, wherein he can use this card to withdraw the cash. Second can be point of sale machine, that is POS machine as we commonly call it. Now in these 2 cases, you physically have to have a card or a device which can act like a card. So these would be called as a card present transactions. On the other hand, you can have online shops like Amazon, Flipkart, wherein you enter your card details through your phone or maybe through computer. And the last option which you can have is your mail order, telephone order, wherein you dial in a certain number. Maybe the example could be Asian Sky Shop or the Naptol, which keep on saying that if you want to buy something, then you need to dial and then punch in your card number or your billing address. So these are the 4 main channels wherein a card holder can initiate a transaction. Now the bottom 2, that is online shop and the mail order, telephone order, which I am going to refer it as MOTO, M-O-T-O, we would classify them as a card not present transaction. The flow is more or less going to be the same as far as card present and card not present transaction. So let's continue with a card present transaction. Let's continue with the process of POS machine. So card holder goes to a merchant like a big bazaar. He swipes his card. Then this POS machine is issued or is linked with the ICICI bank account of big bazaar. So we would call ICICI as acquirer. Why I am specifically using these terms? Because in our later part of the discussion, we are going to use the same terms like merchant, acquirer, issuer, and so on. Now, because this is SBI card, ICICI Bank itself will not be able to process that card. So it will have to pass on that data to interconnect. Now, in this case, we took example as Visa. Alternatively, it can be someone like, say, MasterCard or RuPay. So now this Visa understands that this card belongs to SBI So it passes on the message to State Bank of India, SBI, who is the issuer of the card. SBI checks whether the card is genuine, whether the card holder is genuine, and whether the card holder has adequate balance in his account. If it's a debit card, it would be balance in his account. If it's something like a credit card, then SBI would check whether adequate credit limit is available. If answer to all these questions is yes, SBI will approve the transaction, and the same message will flow till the end, till the merchant level, and the POS machine would show that the transaction is approved. That's how the transaction between card holder and merchant would get over. At later point of time, Visa will calculate how much amount to be paid by SBI to ICICI Bank, and will ask some settlement institution like some bank with which all the banks hold the account. Now this would be the bank which has been designated by Visa. So all those banks who hold a Visa or those who issue the Visa card will have to open an account with the designated settlement institution. And let me tell you, in India, this is not RBI. So in each country, it would be some other bank. It could be your private bank or some other kind of a bank. So in this case, the settlement institution will essentially move money from SBI to ICICI. And that is how the entire transaction flow would get completed. So this is the basic theme of a card process flow. Moving on. So let us understand two key values that we are going to talk about a lot in this discussion. The first is the primary account number, the 16-digit number that you see on the face of this card. Now, as per the ISO standard, this number, primary account number, can be minimum of 13 digits or maximum can be of 16 digits. In India, generally we use this 16-digit PAN. Now, the first digit of this PAN, as you can see here, is a 4, is a network identifier. So from this number, you can actually identify whether this is a Visa card, MasterCard, RuPay card, so on. Now in this picture, you actually see MasterCard with a 4, but because this is a hypothetical number. But then, based on this number, you can identify whether it is a Visa card, MasterCard, RuPay card, Discover card, Amex card, and so on. This is the first number called as a network identifier. Now from 4 to all these zeros, that is first 6 positions, I would call them as a issuer identification number. So this is the specific series, first of all issued by American Bankers Association to somebody like Visa or Master, and Visa or Master would further allocate such kinds of series to various banks who are going to issue cards under those series. So these first 6 numbers could be common to a specific bank. Then from digit 7 to digit 15, as you can see 1, 2, 3, 4, 5, 6 till this 9. These are unique to a card holder. Alright, so each card holder or each primary account number would have all these digits as a unique field. And then we have final digit, which is 9 again here, position 16, is a check digit or checksum. Now generally this is computed based on Luhn's algorithm, LUHN's algorithm. What is the purpose of this Luhn's algorithm? Whenever I enter my card number on a computer or on a phone, or maybe when I swipe a card in ATM or on a POS machine, the card reader would read all these 15 digits first. Now the card reader or the card terminal has this idea of what is this Luhn's algorithm. So based on these 15 digits, it will compute the value of last digit. At the same time, it will compare the computed value along with this captured value of 9. If both of them match, then the machine would say that, okay, the card number is valid, or it will give you the message that your card number is valid. If the computed value and the read value does not match, it means that either the data was not read properly or not entered properly, which means that card transaction cannot be processed further. Now, considering a case across the globe, many a times this primary account number and the expiry date, which is the next part, generally is good enough for carrying out a transaction, maybe along with a card verification value. Not many countries actually implement a second factor authentication. So if I actually want to carry out a transaction, I simply swipe a card. I do not need to enter a PIN, or maybe on online transaction, I do not have to enter any OTP or any additional password, and my transaction can actually go through. So these are the two key values that we are going to talk about in our further discussion. One, your primary account number, and second one, that is the expiry date that you can see here, till what month and year this card is actually valid. Now let us discuss some limitations or vulnerabilities with our traditional MaxStripe card. Now if you compare MaxStripe card with the latest technology of chip card or EMV technology, it has been found out that these MaxStripe cards have been comparatively easier to clone. So you simply create a duplicate card or a clone card and go on swiping. That's pretty easy with MaxStripe card as compared to a chip card. Further, now because this is a MaxStripe card, once the card is issued, it only has a read-only capacity. You cannot change any data on this MaxStripe, right? That is the additional limitation. Now, since this is a MaxStripe, it does not have any processing capacity. So every time you want to carry out a transaction, you have to take it right from the merchant till the end of issuer. And because this transaction path is very high, it would mean that I would always require higher infrastructure cost because I would require to create that path till issuer all the time along with the necessary bandwidth. Every time the data has to travel till issuer, which means the turnaround time would be higher. And because the surface area for a data breach is very high, the risk of data theft is also higher as compared to the EMV transaction. So these are some of the limitations as far as our MaxStripe card is concerned. So if you can see on the right hand side of your image, you see one offline EMV and online EMV. So I will explain on the subsequent slide as well, but when we are talking of something like a chip card essentially comes with inherent processing capability. So many a times in selected scenarios, the card chip itself will decide whether a transaction needs to be approved or it should go to the issuer. So the chip itself will play the role of issuer in certain cases. In technical terms, this is called as offline EMV, that between the chip itself and the terminal, the transaction would get processed and it need not go to till the end of issuer. However, this is only in case of certain situations which have been defined by the issuer as well as the rules set up in the terminal. In some cases, it will still have to go till the end of issuer, what we call as online EMV. But then this chip or this EMV technology allows me to choose between offline, that is between terminal and card, or online EMV. I may still take a transaction till the issuer. But as far as MaxStripe card is concerned, I don't have this option of offline. I only have this option of taking this transaction till the end of issuer. And let me clarify one more thing. When I'm using these words offline or online, I'm not referring to the connection or internet availability. I may have internet availability, but still in certain cases to reduce risk or to improve turnaround time, I may still go for something called as offline EMV. So I have connectivity till the end of issuer, but still I finish the transaction between the chip and the terminal itself. So that I would call it as offline EMV. So when we had such kinds of frauds, or rather such kinds of limitations, what you can see on your screen is something like a data breach, wherein this is from 2017, wherein a huge amount of data was stolen. Right? And you can see the number, it is 143 million. And what was stolen? They stole various details like names, social security numbers, birth dates, but the most important thing that we need to focus upon is credit card numbers. And as I said, in many cases, your card numbers, your expiry date and card verification value, these are good enough to carry out your transaction, right? So these credit card numbers actually are very vital in carrying out a transaction. And once this fraud took place, it was observed that credit card frauds had increased by quite a lot of extent. So the conclusion of this entire discussion is that we have this primary account number and expiry date. Once it is issued, till the card gets expired or replaced, your primary account number would remain static, and so is your expiry date. So if somebody is able to capture your primary account number and expiry date, then he may actually misuse your card. Right? So then it becomes quite essential to protect those details. So that is what gives rise to something called as tokenization. So keep this in mind that in some way or the other, I want to protect my primary account number and my expiry date. Before that, let's finish our discussion on EMV technology. What is this EMV? So this EMV was a group created in 1993 by Europe International, MasterCard and Visa. Later on, this Europay was absorbed into MasterCard. And in December 2004, JCB, which was formerly known as Japan Credit Bureau, also joined this EMV group. Now, what are the advantages given by the circuit chip? As I said, because it is a chip, it gives you an inherent processing capacity. So certain part of the job which could have been done on the issuer side can be done by the chip itself. It gives you read and write capacity as well, unlike your MaxStripe, which would only give you read-only facility. The cloning is difficult as compared to MaxStripe, and plus because I have now reduced the data path, the data may flow in certain cases only between the card and the terminal. The risk, turnaround time, and the infrastructure cost, all of them get comparatively reduced as compared to your traditional MaxStripe card. So those are the advantages which are being given by EMV card. Now within EMV, we have two more categories. So one is obviously the chip card, which gets actually connected with the terminal. But then we also have categories like contactless or near field communication, wherein I do not actually need to insert a card. I can simply take it near the device which captures the data from my contactless card or the near field communication device, and the transaction can take place. So the first two images that you see, this Visa one and one card next to it, are based on the RFID, that is radio frequency identification, and I would classify them as contactless cards. Whereas you can have additional technology wherein you don't physically have a card. The card related data is either embedded in the chip in your phone, or through cloud you connect that in a phone. The next two examples are through phone, or you can have the similar kind of a data in something like a ring, or maybe a wristband, or maybe on your thumb. So what you essentially need in all these cases is a card like data. That's all. And the data should be the device should be able to connect with the POS machine or the ATM, which accepts this contactless or near field communication technology. So in EMV, we can have this chip card, or we can also have this contactless or near field communication card. So these are the two key technologies which are being used at this point of time. So with all this background, let us start discussion on tokenization. So what do we really mean when we say tokenization? It is the process of substituting a sensitive data element with a unique non-sensitive equivalent, referred to as token. So as I said, we have this primary account number PAN and expiry date, which are quite sensitive data elements. Then let me substitute them with some non-sensitive data, and I am going to refer that as a token. Now this token itself does not have any extrinsic exploitable meaning or a value. So in simple words, even if my token gets disclosed to someone else, he will not be able to really exploit that. And how this will happen, let us understand that as well. So we would replace these two key values, primary account number and expiry date, with some surrogate values. So as I said, these tokens could be of three types. One is your acquirer token for card on file. The second is issuer token for virtual card, and we will discuss both of them in brief. And then we would deep dive in EMV token or payment token. Alright, so the first two are typically called as security tokens. Let us discuss what is this acquirer token. Now many times when we purchase through an online website or through app, you get this option: store card details securely for your future orders. Alternatively, many times we choose this option of converting a transaction in EMI at the merchant's place itself. So when we swipe a card, that point itself we select that I want to pay by EMI. Or in third case, I have taken a case of idea. Maybe I could say that every time my bill comes, it should be automatically charged to my card account. Alright, so in all these cases, essentially what is common is that the merchant, or rather the the merchant would have all my card details, like my card number, expiry date, etc. And as I said, because these fields are quite sensitive, I do not want every merchant to store this data. Then what I would do alternatively as acquirer is that I will tell my merchant that what you do not store card data. You give me card data, and instead of that, I will give you a token. A token is nothing but a replacement value. So now, the actual card details remain with the acquirer, and what merchant has are only the tokens, right? And I'm going to talk about something like domain restriction controls. That is the additional part. While we will discuss that in detail at later point of time, let me give you an idea about that as well. When I say domain restriction controls, what it means is that the use of token can be restricted as may be required. So I can say a particular token is available only for paying to idea, or I can say that a particular token can be used only for withdrawing cash from ATM, something like this. So then even if this tokens gets stolen, or if this token data gets disclosed, it is of no use because the token can only be used to pay somebody like idea. That is the whole idea behind this tokenization. Now this would not have been possible with my regular card number. I cannot have this usage specific restrictions based on my card. I cannot customize it further. So in acquirer token, the acquirer would store the card details and merchant would store only the PAN data, the token data. And the acquirer would have this mapping between what is the token value and what is the PAN. So very simple to understand. In case of acquirer token, acquirer will issue the token and merchant will save only the token data and not the entire card data. On the other side, what we have is a issuer token. Now what you see on your screen is a sample of issuer token by State Bank, a virtual card. So maybe I want to do a transaction online, and I believe that there is a possibility that if I enter my actual card number or actual card details, somebody might actually capture them and misuse them. So then instead of giving my actual details, what I do, I create a virtual card, meaning I replace my actual PAN and expiry date and the card details with some fake values, which are only for a one-time use. Alright, so instead of entering my actual card details, what I enter are these fake values. Now these fake values travel across the path till the end of issuer. Issuer already has this mapping that these fake values belong to this card, and based on these values, the issuer is able to process the transaction. But then, till the entire path of this message flow, what traveled over was fake value and not the original card details. And that is why, if anyone is still able to get into that, it will not be useful to him because those were for limited use and those were the fake values and not the real values. So as far as issuer token is concerned, I would say that actual PAN expiry date, I would again replace them with surrogate numbers. The token itself may have a further limit, as you can see here, that while I have a card level limit, the physical card level limit, I can have multiple sub limits or multiple usage limits at the virtual card level itself. I may define whether it's one-time use, it is for multi-use, what would be the value of transaction that can be carried out by such a virtual card, and so on. So these are the added limits which I can have over and above my regular card. So this I would call it as a issuer token. Now let's focus on EMV token. But before actually understanding how this EMV token would function, let us understand the additional entities who are there in this ecosystem. The first one is your token service provider. So who are these token service providers? I would say that they are the ones who are responsible for your token generation, assurance. I will discuss what all these concepts mean when we talk about the process flow. But then they are the ones who are essentially responsible for generating and issuing those tokens. Alright. They are responsible for establishing token domain restriction controls. So as I said, what this domain restriction controls mean? They can restrict usage of a token with reference to specific channels, like is it for POS, is it for ATM, is it for your website transaction, etc. They can restrict the usage to a specific merchant. I may say that this token is can be used only for, say, Amazon. Then in that case, it cannot be used for any other merchant. It can even be restricted based on the consumer device, meaning I have NFC enabled phone, or do I want to actually have it on my chip card? How am I going to use that? So based on the device, I can actually restrict the usage. Or I can also restrict the usage based on the initiator of the transaction. Now, you might feel that all the time it is the card holder who is initiating the transaction. But let's take case of EMI, or on the last page we discussed the case of Idea, wherein your first transaction was initiated by the card holder. But subsequently, say in case of EMI or Idea mobile bill, it was the merchant or Idea who were initiating transaction on a monthly basis with reference to your initial transaction. So in these cases, the subsequent transaction would be initiated by a merchant, not a card holder. So I can restrict the usage of payment token based on the initiator as well. So the whole idea behind this is that even if these details are stored, the possibility of loss gets restricted. So that is as far as my token domain restriction controls are concerned. Now one more thing in process flow you would have thought about, and now since we are talking of this token, you would have guessed, is that because this token would be known only to the token service provider, at the issuer level, I would still need the primary account number, the PAN. So I need some process which can convert my token back to original PAN. That would be called as de-tokenization. Again, this activity would be done by token service provider. And we are going to talk about it next, somebody called as token requester. On one hand, he would be requesting tokens. The token service provider would be interacting with card issuers, that is our regular issuers, and they would be bridging or communicating between the requesters and card issuers to get the tokens loaded on the card holder's device. So the last function of this token service provider is to integrate with token requesters and card issuers. So let me just take you to EMV Co website. So what you see on your screen are the token service providers. So as you can see the names, it has American Express, it has China Union Pay, etc. So it has ID or code. This is a 3-digit, I would say, TSP code, right? And you can find many big players like Discover is there, or First Data, IBM. Then as far as India is concerned, it has, so in this one you have JCB, MasterCard as well. In India, we have National Payments Corporation of India, registered as TSP. You have entities like PayPal, who are like wallet providers, etc., and Visa, Union Pay, etc. So all these parties have already registered as token service providers. Alright, so they are the ones who are basically going to manage this entire tokenization system. Then the additional entity, one more additional entity that we are going to have is a token requester. So somebody who actually needs to request a token. At this point of time, let me tell you that this token requester is not the card holder. Alright, it is going to be somebody like, say, Apple Pay or Google Wallet, who is going to request a token on behalf of your card holder. Now these token requesters are required to get registered with this TSPs. So first these TSPs get registered with EMV, and then these token requesters get registered with TSPs. These token requesters would be given an 11-digit token requester ID. Out of this, position 1 to 3 would be TSP code, and 4 to 11 would be the unique number assigned to this token requester. Now it is not necessary that this token requester has a single ID. It may have multiple IDs to support token domain restriction controls and token locations. When I say token locations, it would mean that what is the storage location of those tokens, something like maybe on chip, or if it's NFC card, is it on cloud, or is it on the secure element, or if it's a device, on what kind of a device are you going to store that. So that is called as a token location. So based on multiple token domain restriction controls or token locations, a single requester may have different kinds of IDs, so that later on the token service provider can actually establish these controls. So that is the whole idea of this token requester. When talking about this token, we have been using this word token multiple times. A single PAN, that is a single primary account number, may be mapped to multiple tokens for different use cases. So as I said, while I have a single PAN, I can create multiple tokens for different usage scenarios. So maybe one for the multiple usage transaction at ATM, maybe the other one only for Amazon, for purchasing on Amazon, and that is again a one-time token. A third one maybe I can create for an EMI based transaction. I purchase something from, say, Big Bazaar, and then I convert that transaction into EMI. That is another token. So I can have multiple tokens for different kinds of use cases. And as I said, they can be merchant, channel, or device specific, or single use and multi-use. Now, cardholders may have multiple payment tokens affiliated with same underlying PAN, since each payment token may have its own domain restriction controls. Now, apart from that, when we discuss the impact, we are going to talk about one more value. At this point of time, let me simply introduce you to that, and then we will have a detailed discussion when we reach that stage. So we are going to talk about one more value called as payment account reference, as a PAR. So far I was using PAN in each and every of my transactions. So all the additional activities, say something like a loyalty based program, or say my anti-money laundering checks, my fraud checks, my data analytics, all of them were happening using primary account number, that is my PAN. Now, if I am not going to disclose my PAN, then what is the mechanism by which I can actually identify these transactions to a specific entity? So that number is going to be payment account reference, that is PAR. We will discuss that in detail when we actually reach that slide. So if I were to summarize, I can say features of token are unique. So it's unique, and it is going to be distinguishable from the PAN, right? So like my primary account number had issuer identification number, etc. Similarly, my token number is also going to carry a specific series which I can use for transaction routing, and going to have the same kind of syntax or format like my original primary account number. The idea is that we do not disturb the ISO 8583 fields or the messaging fields. We can use the same fields to capture token number instead of a primary account number. Then next, as I said, it will link the underlying PAN and the affiliated payment tokens, right? Then it will help me to route. So as I said, it will have something like issuer identification number, while I will call it as a BIN, bank identification number. So like my primary account number, my token number would also have a BIN, based on which I can understand what is the kind of a product which is being issued based on the series, and I can also use it to route the transaction to the correct issuer. So that is another feature of a token. And it should be able to operate as if it's a PAN. So while I am replacing the value, all the features of the PAN would be there for a token. But then, apart from my regular PAN, I get something additional as my token domain restriction control. So my token would operate as a PAN plus give me some additional restrictions. Now let's talk about the EMV token issue process. So I am taking an example, which is a near field communication enabled phone, and Apple Pay is the token requester. On the other side, I have a bank, which is the issuer, who has issued the card to the cardholder. So as a token requester, Apple Pay would request for a token. Now whenever this information is being passed on, it would use the primary account number, which is there for the card. In this case, I am assuming this Visa, Master, Amex or Discover to be token service provider. So the Apple Pay actually sends out this request for token to token service provider. This token service provider sends this request to the bank, but not for the purpose of creating a token, but for something called as identification verification, or ID&V. I can also call it as identification and validation. So what is the idea of this ID&V? So when the request has come from the cardholder or from the token requester, what I want to ensure is that this account or this primary account number is still valid. All the details being captured are right. So I want to ensure that the request has come from the right source. And how am I going to actually do that? There are multiple ways by which it can be done. Maybe the bank might transfer a single rupee to that account or to that card and check whether it is the right one. Or in some cases, I can have one-factor authentication, like I ask the user to enter his username and password, or I may ask him to use his biometric. Like many times we have phones which have a fingerprint scanner. So using this biometric, I may say that I want to authenticate the card holder. I can have a two-factor authentication as well. So like I have one password plus say biometric. So under this two-factor, I may divide it into further categories like something which the card holder has, something like a token, or maybe an RSA key or something like that, or a device, specific device, specific card, something which the card holder is aware of, something like his unique password. So based on that, I can actually carry out something called as ID and V. So whenever this request comes to the token service provider, first of all, he would have to check whether the details under the request are valid or not. Now, at the bank level or at the issuer level, the issuer is already expected to have carried out the KYC of their customer. So then as far as this tokenization is concerned, this initial KYC is not within the framework of EMV token. Alright? But then the additional validation which is being carried out at this step number 2, is governed by the EMV, and that is why it has the other way around arrow as well. So then bank would respond whether the data given to them is correct or not. Once this identification and verification is done, I would introduce one more entity as a token vault. Now this token vault would have this mapping of it will create a token first. It will create a token number based on the bin range that has been allocated to that specific issuer or that specific token service provider. Based on that, it will first generate a token. Now, this token vault will only have details, or I would say mapping between my primary account number as well as the token itself. So here I create a token preparation and issue. So it will give back the token details to the token service provider. And through the token service provider, through the token requester, the tokens would get loaded on the device, that is the NFC enabled phone. So that I would call it as token activation. So then essentially what I did at step number 3 was token preparation or token issuance, and then taking it to the end device is called as token provisioning. Alright, so those are the key terms which are being used in the EMV framework. So first I had request for token, then I had ID and V. I can have various methods by which this can be carried out. Right, so there are various categories which have been defined in the framework, technical framework. Based on this categorization or based on one of the methods, the issuer actually carried out the identification. He said that okay, the given details are correct. Then at the token vault, actually the token numbers were generated based on the allowed bin ranges. Then these tokens were issued to the TSP, and through the token requester, they went on to the device. That I would call it as a token provisioning. So in this way, using my original PAN, now I have tokens loaded on my phone. So when I say token loaded on my phone would mean that I have captured all those token numbers, their relevant expiry dates in my phone. Right. So now next time onwards, instead of giving away actual primary account number, what I would use are these tokens. So that is about my token issuance process. Now let's talk about the token usage process. Let's see how will that happen. So we are taking a case where this NFC phone is taken to a POS machine, which is again NFC enabled. So now instead of giving away the PAN, what this time the phone would give is the token and not the PAN. So the merchant through the network connects to the acquirer. Now what gets passed on is your token. Acquirer then eventually passes on to the token service provider. Right? At token service provider, using the token vault, it would be de-tokenized, meaning this token values would be reconverted into the primary account numbers. Why? Because at the issuer end, what issuer would want are the primary account numbers and not the token values to approve or reject the transaction. So then, once the primary account numbers are given to issuer would carry out his normal process, checking whether the card holder is genuine, whether the card is genuine, and whether he has adequate amount of balance. If answer to all of these are yes, he would approve the transaction. And when he actually responds with this message that a transaction is approved or maybe in some cases rejected, it will still take place using this primary account number. So as far as this process flow is concerned, it would still use your primary account number and not the token value. However, on its reverse path from my token vault or from token service provider till the end of merchant, I would re-tokenize it using the token details. So what would flow back are the token details and not the original primary account number. So in essence, as far as my primary account number was concerned, it traveled only in this box. So in other words, what happened is that the risk of data theft was restricted to this box because in this entire path, what traveled was a token and not the primary account number. That is how my EMV token process usage would take place. Now let us understand what are the impacts of this on the other processes that we were discussing. So first of all, let us discuss on the ISO 853. So you may be aware that ISO 853 messages are being used for communication, right? So let us understand what kind of impacts are going to happen on ISO 853. So I am only discussing the key changes. There are few more other changes which are not really key. So you may refer the EMV technical framework for the same. But let us discuss the key ones. So as I said, the idea or the constraint or the assumption behind this entire tokenization is let us not affect the other systems, let us not affect the other processes that we already have, and let us go on using existing infrastructure as we have. So that is why it says that fields for PAN, that is your primary account number, field 2 in ISO 853 message, and PAN expiry date, field 14, to be used for carrying payment token and token expiry dates. So I'm not going to create a new field for carrying out this token number or token expiry date. What I'm going to use are the existing fields only. The additional key fields which would be designated would be for your token request indicator or token requester ID. An interesting thing as last 4 digits of PAN. Now let us understand, on one side that we are saying that my PAN details should not get disclosed anywhere. But at the same time, we are also saying that there should be one additional field designated for last 4 digits of PAN. Let's spend a couple of minutes on discussing this. So understand that right from your merchant till the end of issuer or till the end of token vault, what traveled was payment token. So at the merchant's end on the device, what would get showed would ideally be a token number because ideally it has not identified what is the PAN. But then think you are a consumer. You get a charge slip and it has some weird details or weird numbers which do not match with your card details. You physically hold a card or you are aware of card numbers, but then what you see on the screen of that device or what you see on your charge slip could be something completely different. So then, to avoid such kind of a scenario, we would still capture last 4 digits of my primary account number. So as a consumer, I'm aware that it's my card or my wallet which is being used. That is the only purpose of capturing last 4 digits. So I still maintain secrecy about the initial digits, but just for identification purposes, I use last 4 digits of the PAN. Then additional fields could be required for the PAN product ID and payment account reference. So we are yet to discuss about what is this payment account and payment account reference. As far as EMV based applications are concerned, following tags have also been defined. Tag 9F24 for payment account reference, tag 9F25 for last 4 digits of PAN, and tag 9F19 for token requester ID. So if you have applications which are already EMV based applications, then these specific tags would be used to capture these specific details in case of a tokenization. So that is the one impact that we see on the messaging side. So my ISO 853 messages need to change to a certain extent, and then I need to configure my applications to read these specific tags as may be required. So that is the impact on my messaging. Now let us also discuss impact on honest transactions. So let me just take a couple of minutes to explain you what is an honest transaction and what is of-us transaction. So on us would mean both my issuer and acquirer are one and the same. For example, I take ICICI card and I use it on the ICICI ATM itself. Or I go to a shop, say Big Bazaar, I have my ICICI card and Big Bazaar's bank or the acquirer bank is also ICICI. So in that case, issuer and acquirer, both of them are one and the same. Such kinds of a transaction, I would call them as on-us transactions. On the other hand, what would of-us mean? Exactly the opposite of that. So I have one issuer and different acquirer. So say as we discussed on our first slide that I had SBI card. So SBI was the issuer, whereas that was being used on ICICI issued POS machine. So ICICI was my acquirer. And that is why to link this issuer and acquirer, I needed some third party like Visa or Master who could do this transaction for me. So prior to tokenization, we had a simple scheme. I have card holder, I have merchant. In this example, I've assumed that the card is also issued by SBI and merchant also deals with SBI. So acquirer is also SBI. In this case, we did not require any third party like Visa or Master. We simply captured primary account number, transferred it to SBI. SBI decided what is to be done with this transaction. Either it approved or either it rejected and then gave the result. But the key thing to note here is that it was completely through the primary account number. Now let us understand what would happen post tokenization. So I have a card holder who has this SBI card. Once he uses this card, what would now get transferred is a token and not my primary account number. For merchant, it does not really matter whether you capture a primary account number or token, he simply passes it on to SBI. But at this point, now because SBI gets a token, SBI does not understand whether this card belongs to me or not, right? So for SBI, it is like of-us transaction only because SBI does not have this mapping between token and the related primary account number. So it has no other option but to send it to the token service provider. Here I have taken a case that the network and token service provider are one and the same. So this token data then flows to Visa, who is the token service provider in our case. Visa would then, using token vault, would de-tokenize this information and send the primary account number of the card holder. Once this data is received back by SBI, now like our regular usage flow, SBI would check with this PAN whether the card holder is the right person, whether the card is genuine and he has balance, and then he would approve or reject the transaction and he would respond to this message. Again, in responding to this message, he would have to use PAN because now he is playing a role of issuer. So he responds back with the primary account number. However, if it has to go back to the merchant or to the acquirer, it has to be re-tokenized. So then Visa would re-tokenize it, send it back to SBI. Now SBI is acting in the role of acquirer and then it receives the response as transaction approved or rejected. But this time the underlying is token number and not PAN number. So the details are now with SBI. The token moves back to the merchant and based on this token the reference, either the transaction is said to be approved or said to be rejected. So earlier when we had such a small cycle, once we have this tokenization in place, the cycle of transactions is going to increase. That is another impact. Now to avoid such kinds of impact, many a times the banks, what they have done, while it may directly go against the concept of tokenization, with implementation of additional controls, what they have done, as far as tokens or bins which are related to cards issued by those banks, they have also mapped these bins in their own database or in their own switches. So then, whenever a token comes at this stage, they are able to identify that this card belongs to me. And based on the mapping, based on the de-tokenization done by the banks themselves for card issued by them, they are able to avoid all this process flow. That is how some of the big banks have done so far. However, considering the ideal scenario, which is given by EMV, that the token and the PAN mapping should be there only in the token vault and not at any other place. Considering that mapping or considering that concept, the flow would change and would have these multiple cycles. That is another impact as far as on-us transactions are concerned. Now let us also discuss impact on other processes. As I said in our earlier discussions, that following processes currently use PAN, that is your primary account number, as common parameter to aggregate transactions of a card holder. What all kinds of processes? I have listed some examples. So merchant or acquirer risk management and fraud checking. So as you would be aware that under the AML guidelines or combating financing of terrorism, or from detecting fraud perspective as well, everybody is required to analyze the kinds of transactions, right? Is there any potential fraud or potential money laundering which is happening? So for those reasons, what was being considered so far was a primary account number. I would aggregate those transactions, or I would identify all those transactions based on primary account number. But then now onwards, what is going to happen is that each time I use a separate token, and as a merchant or as an acquirer, I do not have this link with the underlying PAN, right? So then that becomes an issue for me. I cannot really aggregate all those transactions or identify all those transactions to a single PAN. That is the difficulty being faced. Similarly, you have merchant-based loyalty programs. Now, many times you have these loyalty programs like say Domino's. So if you go on using Domino's or somebody like say Grand Sheraton or Marriott, then they would giving additional points, right? Now, not all of them give you a separate customer number or customer identification card. They may still rely on something like PAN. So if you go to a Domino's shop, you swipe a card, they would understand that okay, it is you. Or maybe you order online on the Domino's website and still use the same card, they would still understand that the transaction is being carried out by the same customer. So such kinds of a loyalty program which are dependent upon PAN would again be affected. Many a times you would also be aware that the banks, issuers or acquirers, they also carry out various types of analytics, right? They analyze your spends, they analyze in which areas or which kinds of products do you spend, right? And then they are able to give you value added services, or they are able to customize the offerings given to you. Now again, the underlying thing is that so far what was being used to aggregate all these transactions was PAN. But now the limitation being that the PAN is not available to all the entities, there has to be something else which can actually give me or which can enable me to carry out such kind of processes. So then, as far as tokenization is concerned, it was identified that there is some data or some constant value. My token is a dynamic in nature. So based on every transaction type or based on usage, I can have different tokens for a single PAN. But then I need one more value which is actually constant in nature so that I can identify, aggregate and analyze the transactions which are linked with a single primary account number, right? But then if I again go back to a constant value, what happened with PAN that I could simply misuse that, the same would be applicable for this constant value. So then this constant value shall not allow me to initiate a transaction or route the transaction like I was able to do with the PAN, or rather, and I would create this constant value in such a manner that I should not be able to trace it back to the PAN as an ordinary person. So only the trusted entity who generated this data would be able to link it back with the PAN. So these are the two key things which we need to think. That one, in one way it has to be a constant or a static value so that every time this is being used, I can identify and aggregate the transaction with respect to that value. But then it should also restrict me from initiating a new transaction or routing a new transaction. So now this new value we are going to talk about is called as a payment account reference or PAR. Okay, so we have this new value which would now be considered as a replacement of PAN. So if you remember our earlier discussion, we said that in long term we are going to replace PAN with PAR. But when I am using the word replace, it would not mean that I would not be issued a PAN and I would be issued a PAR. My PAN will still continue to exist. As far as my transaction initiation and routing is concerned, what I am going to use is a token. Whereas whenever I want to aggregate these transactions, what I would have to use is a PAR and not a PAN. So now I get both the benefits which I had with the PAN. I can initiate the transaction using token and I can still analyze it using this PAR data. I'm using this 9F24 based on the tag in EMV field. Now let us understand what is this payment account reference. It is going to be a fixed length 22 character uppercase alphanumeric data element. The first 4 characters are the bin controller identifier and remaining 25 characters are unique. So how do we then calculate this 25 characters? This method is dependent upon the bin controllers. They are required to tell that how this PAR data should be populated. And as I said, it should be populated in such a manner or computed in such a manner that it should not be reverse engineered to the original PAN. That is the whole idea. Now this PAR is a non-financial reference assigned to each unique PAN and used to link a payment account represented by that PAN to the affiliated payment tokens. Right? Let me also discuss this, what is this payment account, and then I will explain both of them together. Payment account is a representation of the unique financial relationship between account holders and financial institutions for a specific financial funding source represented by one or more PANs assigned to the card holders. In simple terms, what a payment account would mean, say in case of your debit card, your saving bank account is your payment account, or in case of a credit card, your card account is your payment account. So that account through which, or that account which is actually going to be get affected by the transactions would be called as payment account. So whenever you swipe a card, the account which is going to get debited, I would refer that as a payment account. So now we need to consider one more thing, that it says the account represented by one or more PANs. So let's say take a case of add-on cards. So husband and wife have a card, but then wife has an add-on card. Whenever even she swipes the card, it is the husband's account which gets debited. So you can have a single payment account, but then it can have multiple primary account numbers associated with that. So one payment account and one or more PANs. That is the first level of relationship that we are talking of. Then this PAR or this primary account reference is nothing but the number which represents this link between this PAN and the payment account. That's the first part of it. So for every PAN, I am going to have each unique PAR. For every PAN, I am going to have one PAR. But then, as we discussed in our initial phases, that for a single PAN, I can have multiple tokens based on the domain restrictions that I have. Right? So I have one payment account under which I can have multiple PANs. For every PAN, I will have a PAR. And now, because for every PAN I will have multiple tokens, then all those tokens would again be linked back to the same PAR, because my PAR and PAN have one-to-one relationship. Correct? So now whenever I actually transact using different kinds of a token which are created or which are affiliated with the same PAN, all of them would also have same PAR. Correct? So then as a merchant or as acquirer, instead of aggregating transactions at PAN level, I can now start aggregating them at PAR level. Alright, so that is the significance of this PAR. So as I said, this PAR will have one-to-one relationship with PAN and one-to-many relationship with tokens. Now one more thing to be noted here. Now let's say a card gets expired and a replacement card is issued. Now the replacement card may have a different primary account number. Correct? As far as PAR is considered, then in that case, the PAR would still remain same for the replaced PAN. So then what PAR would ensure is that even though there could be multiple events that may occur in the life cycle of a primary account number, the PAR is going to be constant across the life cycle. So even if my old PAN gets replaced with a new PAN because my original card got expired, my PAR for both of them would remain same. All right. So even if there are multiple events, life cycle events in the PAN, my PAR data is going to be the same. Now this PAR value must be generated in such a manner that it cannot be reverse engineered to understand what is the underlying PAN or payment token. From PCI DSS perspective, now many of you would be thinking what happens from the PCI DSS standpoint, that is your payment card industry data security standard. So if under PCI DSS, if something gets classified as your account data, then various types of requirements get applied. From PCI DSS standpoint, this PAR data is not considered as account data. So wherever I am storing this PAR data, that would not be classified as an account data. However, one key thing to note here is that whenever I am storing this PAR data along with its mapping to the PAN, or whenever I am processing this mapping of PAR data and PAN, that would still be classified as account data and would fall under the PCI DSS scope. But when in isolation, whenever I am storing this PAR data, like as I said, on merchants database or on Aqua's database where I am not mapping it with the underlying PAN, in those cases, I would not classify that as account data under PCI DSS. So from that standpoint, it needs to be understood that my PCI DSS compliance cost or requirements gets reduced to a certain extent. In earlier scenario, whenever I was storing PAN and the other card details, those were getting affected by my PCI DSS compliances. But with this introduction of PAR, those would be gone away, right? So that is the concept of PAR. So whatever I had to discuss on this tokenization, I have completed my discussion. In couple of minutes, we will start with our question and answer session. Before that, let me spend 2-3 minutes on the various program of MVLCO as far as cards are concerned. So the first one is Introduction to Payments and Cards. It is essentially a one-day program. I believe some of you have already attended that. So it gives you a brief overview of what is payment and settlement. It gives you generic understanding of RTGS, hybrid RTFS and ACH technique, that is automated clearing house. Here RTFS is nothing but a technique for your something like IMPS, instant payments, right? Then it also gives you details on SWIFT and ISO 20022, that is as far as the payments portion is concerned. As far as cards is concerned, it gives you understanding of cards, the process flow for honest office transactions, ISO 8583 and EMV basics. It also gives you details on switch, HSM and key management. It's a one-day course. There is no evaluation. As of now, the next batch is not scheduled, but if you are interested, do get in touch with our training team. The next course focusing on cards is the Certified Card Payment Systems Professional, which is CCPSP. This batch of CCPSP has been scheduled from 11th to 14th July in Pune. It's a 4-day full-fledged course focusing on all the functional and technological aspects of the card. So whatever we discussed as far as tokenization was concerned or the NFC was concerned, we would discuss that in much more details, because this course focuses only on cards. So how the keys would function, how are PIN created, how are they actually transferred, what are the EMV tags, EMV standards, how do these transactions get processed, the card frauds, etc. Now this is an certification course, so you would have an exam, an online exam, and once you clear the exam, you would be issued a certificate. Now again, I believe some of you have actually completed the CCPSP course as well. And the last one, which purely focuses on payments, is Certified International Payment Systems Professional, that is CIPSP. So it gives you much more details as far as this RTGS, hybrid is your NEFT systems, RTFS, ACH, along with the various kinds of risks which are associated in payment systems. How are they actually implemented in regions like USA or Single Euro Payment Area, Canada and Hong Kong? So while in introduction we talk of the generic, we actually get into specifics as far as this 4-day program is concerned. We also discuss how are the blockchains supposed to work. We also discuss SWIFT and ISO 20022. Now let me tell you, ISO 20022 has been accepted as a global standard in a way that by 2025, all the payment systems have decided to migrate to ISO 20022. As far as cards are concerned, in SEPA region, ISO 20022 has already been implemented, and even the card messages are intended to be migrated to ISO 20022 in the near future. So that is the significance of ISO 20022. Again, this is a 4-day program, and it is a certificate course, so which would mean that an online exam would be assigned to you post the course. And once you clear the exam, you would be issued a certificate. Now, maybe just to check the popularity of these courses, you may go to LinkedIn and actually search by CIPSP or CCPSP. You would find a lot of people who have already completed these certifications and working in various IT companies or banks. So next batch of CIPSP has also been scheduled, which is from 1st to 4th August in Pune. So you may get in touch with our trainings team. Their email ID is there, and our website details are also there. You may also get in touch with them using phone. So thanks a lot. It was pleasure talking to all of you. Thanks for your enthusiasm. Please get in touch with our trainings team if you have any feedbacks or if you have any inquiries. Thank you.